Hello, and thank you for taking the time to view this feasibility study for a research proposal presented from the University of Houston Victoria's Sugar Land campus over reducing the impact of hurricanes on the U.S. by creating vegetation in the sub-Saharan region, presented by myself, Eve Gans, and contributing professor Dr. Soma Sundaram. For this presentation, we will be covering the history and background of hurricanes and where they originate, how we can reduce the impact, and the long-term benefits of this project. In this video that you're about to watch is of the hurricane that struck Galveston on September 8, 1900, and still considered to be the deadliest on record.
Entering the 20th century, Galveston was a major center for export and banking. But on September 8, 1900, all that changed. With little warning, the city was destroyed by a massive hurricane, estimated at a Category 4 by today's standards. Floodwaters were so high they pushed buildings off their foundations. Many were broken into pieces. All that was left was a tangled mess of rubble, upwards of 15 feet high, smashed timbers, parts of buildings and houses, and hundreds of dead bodies. More than 6,000 people lost their lives in Galveston in the hurricane of 1900. Still considered the deadliest natural disaster in U.S. history.
As just mentioned in the previous video, this is one of the deadliest storms on record. What was not stated, however, is that the inland areas were also affected and that the estimated death toll reached a staggering 20,000. This happened a long time ago, so you may be questioning at this point, what does this have to do with us now? This next video will help you understand a little better just how devastating a hurricane still is to the U.S. and the toll that it takes on our economy and our lives.
On August 29, 2005, Hurricane Katrina pounded the Gulf Coast. In some areas, storm surges nearly 3 stories high wreaked havoc on coastal and inland communities alike. Whole towns were devastated, some nearly wiped off the map. In New Orleans, a levee breach sent water flowing into much of the city, leaving tens of thousands homeless, many stranded in their homes for days. In economic terms, Katrina was the most destructive storm to ever strike the United States. It was the costliest and among the most deadly. Official estimates list total deaths from the hurricane and its aftermath at over 1,800. And while Katrina's effect on New Orleans remains etched in our minds, the hurricane's storm surge by far reached its highest levels in Mississippi. Gulfport, a storm surge at about 28 feet. All along the coast, block after block of homes and businesses destroyed, some swept away by the water. Katrina's eye focused on the Louisiana-Mississippi border, with the storm's stronger east flank lashing Mississippi's coast with 120-mile-per-hour winds and an unimaginable mountain of a storm surge. The coast has yet to recover fully.
As we just saw and heard, the U.S. is still susceptible to a hurricane's destructive force in this current era, and at a cost of over $100 billion. Now let's take a look at what part of the problem is. This is a model of the original forest area approximately 8,000 years ago. This is the same model, but just in the past 30 years, we have lost nearly half of the Earth's original forest due to deforestation. Currently, we are losing 20 to 50 soccer fields every minute per day, and at this rate, in just a few decades, we will be at a 90% loss of the Earth's forest cover. This amount of deforestation has led to higher temperatures and, as a result, higher African easterly jet streams that cause extreme low-pressure systems to enter the Atlantic Ocean. These low-pressure systems form tropical storms that turn into major hurricanes and eventually impact the U.S. NASA has captured these jet streams on satellite as they pass over Africa and enter the Atlantic. As you can see from this image, the jet streams pass over the sub-Saharan region, building in intensity. This force creates the low-pressure systems, first form in a tropical storm, and then into a hurricane known as this one called Hurricane Isabel. Isabel reached a Category 5 status, that is winds sustained over 156 miles per hour for over 30 hours in the Atlantic, and grew in size. It eventually hit the U.S. as a Category 2. This storm still cost $3 billion in damages, 50 deaths, and affected 8 states as a result. Here are the facts. Over the past 30 years, hurricanes have increased in frequency and intensity due to the rise in atmospheric and oceanic temperatures. Just an estimated 1.8 degree rise in temperature will increase a hurricane intensity by 5%. The majority of hurricanes originate from easterly jet streams off the coast of Africa. We also know that one average tree absorbs approximately 2,000 pounds of carbon dioxide per year. The projected amount of carbon dioxide absorption for this proposal is approximately 400 billion pounds per year. Now there is debate as to which came first, the carbon dioxide or rising temperatures, kind of like the old adage of the chicken or the egg. But I'm not here to debate that point. Ultimately, there is a correlation between the two, and if we can remove a large amount of CO2, there should be a direct response on temperatures as a result. We must act now and not just talk about these problems. As stated earlier, we are losing forested areas at an alarming rate every day. Trees release water vapor into the atmosphere. The amount of trees in this project can eventually transform an ecosystem from arid to tropical. This conversion of water to air vapor is a chemical process that removes heat energy from the air, in turn lowering temperatures. The added shade, reduction in temperatures, and moisture in the air allow new growth to take place and increase survival rate of the plants. Now we will move on to the possible solutions to reduce hurricane impact. In this proposal, the neem tree will be the initial plant chosen for establishment in the sub-Saharan region. At maturity, one neem tree can cover up to 900 square feet. Within 3 to 5 years, the neem tree seeds can be harvested and used by the local communities to establish even more plant growth in the area. Neem trees reach almost full maturity within 10 years. This allows the benefits to be seen as a result of lower temperatures and CO2 levels in a shorter amount of time. Benefits of the neem tree are that they are fast-growing, drought-tolerant, and a native species to the region. The neem tree actually consumes more CO2 and produces more oxygen than any other tree. There are over 100 medicinal properties in the neem tree, including anti-malarial properties. This is beneficial and crucial to the region in Africa. Once they are an established plant, they can be used as natural pesticides on crops in the local regions versus using harmful chemicals like DDT that are still used overseas today. This chemical was banned in the U.S. because of the destruction on our environmental resources. Many people have questioned, how in the world will you plant in the desert without water? We have found the solution. A product called Groasis Water Box by AquaPro has developed a self-sustaining water system to increase the survival rate of plants in desertification areas like the sub-Saharan region. Currently, the price of the box is $28.50. As demand for the system increases, the cost may go down. A biodegradable version of the box is being tested currently and will be available later this year. The water box has proven results all over the world and a 90% success rate in plant survival. To help give some insight into the system of the water box, I will briefly detail the process. A horizontal planting space is marked and dug out. This provides rainwater to be efficiently collected and prevents evaporation. Using a compass, determine north and set the box in alignment. This allows the sleeve opening to face east and west, protecting the plant from direct sunlight during 10 and 4. The paper board is set facing north and is used as a marker for the plants. Using the paper board, you will mark the spaces for planting. Next, dig out small holes that were marked from the previous paper board. Always try to select seedlings that have a good root system. This will increase the survival rate of the plant. Place the seedlings in the marked location. The paper board is placed over the seedlings to help prevent evaporation. Seeds can also be sown in place of seedlings or in a combination. The box has a capacity for 3 different types of plants. This will increase the survival rate for each box planted, especially if one plant happens to fail. This can also add biodiversity by planting a tree and a bush together in the same box. Here is an example of 3 trees that have been planted in the same box. A wick system is installed into the bottom of the box, and this allows reserved water to drip out slowly and provide a constant source of water to the plant. The box has an option of adding wind protectors. This is necessary for areas like the sub-Saharan region where strong winds are prevalent. The box is placed on top of the plants, making sure to align the box with the paperboard marker underneath, and that the seedlings are in the middle of the opening. The added wind protectors are nailed into place, and the isolation plate is placed inside the box. This helps to keep the water temperature low and keeps the light out to prevent algae growth. The cover is placed on top and clicked in place to secure. This design keeps animals out of the water source, as well as the design acts as a funnel to catch additional rainwater. Initially, 4 gallons of water are added to the outer reserve and 1 gallon to the central opening. This is the only provided source of water needed. The rest will be self-renewing through condensation or by additional rainfall. Siphons are added to the top of the lid. This helps funnel additional rainwater. In the final step, the top cap is replaced and secured to prevent evaporation and unwanted animals from entering the reserved water source. Here's the completed system, and when the plants reach a couple of feet above the box, it can be removed, and the box can be reused. Or with the biodegradable box, it can be left into place to decompose, providing added nutrients to the plant and soil. Here at the University of Houston Victoria's Sugar Land campus, we have started this year our own research park and are testing out the water box as well as the neem tree. The assembly went well and the box was easy to put together. We chose a non-irrigated area and did not fill the boxes with water since rain was expected the following day. The rain fell the following day and the water box system was completely filled as expected. After just 1 month and no additional water, there is new growth on the neem tree already. Same plant at 5 weeks, and at 6 weeks still growing. Also in our research park, we have a weather station that is monitored by the University of Houston Victoria main campus. This will allow us to gather information on the neem tree effect on CO2 levels and O2 levels once they reach maturity. Right now, we are in the feasibility and proposal stage. In Phase 2, we will secure funding through grants, private sectors, and government agencies and start taking action once funding is in place. In Phase 3, we will work with other universities to start a study abroad program. This will provide much needed support for the program and other educational opportunities to students as well as the local communities in Africa. Phase 4 is considered to be long-term. The research that will be extended to all students is boundless, from environmental ecology to meteorology, and the benefits will be reaped by not only the U.S., but in Africa as well. The projected planting phases will take place over 4 years initially, reevaluating after each term to make improvements. The first phase will take place in the Republic of Mauritania. Second phase will be in the Republic of Mali. Third will take place in the Republic of Niger. And in the fourth phase, the Republic of Chad. The 4 republics just mentioned make up a part of the sub-Saharan region, also called the Sahel Belt. In this picture, the pale yellow indicates the arid region. An arid region is considered to be sparse in vegetation. In this proposal, we suggest that planting should take place along these regions, and in order to maximize the efficiency and survival rate of the plants. Now that we have designated the locations for planting, we need to discuss how many trees to plant. While half of each region needs to be reforested, we have to be realistic at first to our capabilities. We propose that 500,000 new trees can be planted in each republic. After the 4th year, the original plantings in Mauritania can be harvested by locals and, if research is extended, by the students. The harvested seeds can be sown to produce more trees and eventually a continuous cycle. The cost of each republic's initial planting is $14.2 million. From our projections, each phase can be accomplished in 6 months over the course of 4 years. We will be able to use research students in the study abroad program to actively plant during the 6-month terms. Students will be on a 6-month internship. Possible grants can be written to offset travel and living expenses. Just to give an idea of how this can be accomplished is if we have 30 students in our abroad program, plant 92 trees per day for 30 days over the course of 6 months, we will have planted approximately 500,000 trees. For the skeptics doing the math, that's 10 to 11 boxes planted per hour in a typical workday. Of course, the local communities will also be utilized for volunteering, and this will help offset the amount of planting needed by the students. There is no doubt that this will take a lot of dedication and hard work, but if we are all working together, this is an achievable project. The projected cost of the 4-year proposal is approximately $57 million. Compared to the cost of one hurricane that is in the billions, this is a fraction of that cost and can eventually be a financial gain to those who invest. An investment in this project has benefits on a global scale, from reduction of hurricane impact on the U.S. that cost us billions of dollars each year, to helping build up the economy in Africa, all while creating new jobs. The long-term benefits will be an overall temperature reduction in the sub-Saharan region, which will in turn reduce the hurricane impact on the U.S. We will also be helping stop desert encroachment along the Sahel Belt that is taking over local communities, as well as providing extended research opportunities to monitor project results. In addition, we will be adding to the biodiversity of the region by increasing the amount of vegetation, which will attract more wildlife to the area by providing more habitat to access, as well as creating an atmosphere for other plants to be able to survive. We will be reducing deforestation that needs to be a global goal, not just in the sub-Saharan region. With our success, we will become a leader in other global projects and be able to provide our expertise. By working together, our international relations will strengthen. We are in current collaboration with Dr. Didi Faye, an entomologist and founder and president of Africa Bound and the Senegal Neem Foundation, as well as Dr. Ramesh Saxena, the chairman of the Neem Foundation in India. Both gentlemen have already been active in the production of the neem industry and have had success in reforestation projects abroad. They have dedicated their resources and experience to help in this project. I would like to leave you with this quote from Ernest Hemingway that states, "Never mistake motion for action." Anyone can go through the motions of this project, but we have to take action by coming together as universities, countries, and communities. You can be a part of this great project by donating to the University of Houston, Victoria, or when the study abroad program begins, apply for an internship. If you have any questions or would like more information, please feel free to contact us at the emails below.